Okay. Hello everyone, welcome to Handmade Hero, a Monday Handmade Hero. So we're back after a weekend. I hope everyone's programming brain has had a chance to recharge and is ready to forge ahead, because forge ahead we will. Again, Handmade Hero, we are in the process of writing an entire game from scratch using no library and no engine. A daring feat of strength. Like I said, just me and 1,000 of my closest friends here on the Twitch chat. And it's been going pretty good. We're sort of cresting a very important stage in our engine design right now. We're basically at the point where we're trying to figure out exactly how we want everything in the engine laid out so we can go implement the various components. And so what's interesting is we're at a point now where we're finally getting to where I think we need to be in terms of like managing the entity and the world state in kind of a good way. And we're at a point where we're trying to play around with that stuff to make sure we get it right. And it's just about getting to where I'm starting to feel like it's good. And so that's kind of exciting, because once we can kind of lock that down and move past that's like sort of another big notch that we can sort of say, okay, we're good. So I want to get right back into that. Even though it is a Monday, I'd like to get started. To dive right in. So what I will say though is where are we at? We're at day 56. So what you want to do is, if you have pre-ordered the game on handmadehero.org, you should have got a link in your email. If you go to that link, you can download the source code zip, and that source code zip should have the zips for every day's source code. So since we're on day 56, go ahead and unzip day 55 source code into a directory, and you'll be exactly where I am if you want to go ahead and follow along with what we do on today's video. So where were we? Basically what we had done on Friday is we had just sort of gotten to the point where we had our entities partitioned into two sets, a low frequency and a high frequency update set. And we also had it so that the entities, everything was now being done in entities. So like walls, like these walls of this room here, room, and I use the term loosely, are being defined as each little individual entities that kind of go around the perimeter. And we had started to actually do the work of, as the camera moves around, sort of move entities into and out of that high frequency set. And so what we were doing is, if you remember, let me see here if I have let me bring up the editor. I'm not going to do much coding without an editor. So we have the set camera call, and what the set camera call would do is, every time we move the camera, it would sort of look through here and go, all right, we have everybody, who's sort of, when the camera moves, we have everyone who's going to now become outside of the bounds of the camera that we want to simulate, outside of the area that we actually want to simulate. So we're going to move them into the low frequency area. And this offset and check frequency by area call basically takes care of all those guys. It goes through and looks, and it moves them out. And so that's pretty much like, there's not much about that I'm uncomfortable with. That's basically what we want to do, because this high frequency entity set is the set that we're actively dealing with. And especially on a very fast CPU like the one we're working with right now, that's probably fine for a while. Like, we really don't have to worry about that hardly at all, because the number of things that are in that set is very low, right? By the way, I tried installing, someone was recommending Mischief as a drawing program, so I'm going to try it. We're trying a new drawing program today. We'll see how it works. So if you remember, we had a situation where you basically had if this is the screen, this is what you can see. Then there was sort of an apron around there, and we're basically saying that any entities that fall within this region, we're going to simulate at high frequency, right? And then everything outside of there that's in the rest of the world is going to be simulated at low frequency. So people out here are not going to be getting the same attention to detail as people in here. And the reason we did that was for scalability, right? So we want to have good scaling in our game. And I don't mean things getting bigger and smaller. I mean the ability to scale up to very large numbers of entities that are all acting independently. And so let's say we have a game world that's very large. Let's say we have huge numbers of entities. We've got 100,000 entities out there, or more, 1 million entities, who knows how many, right? Just a huge number of entities. And we want to make sure that we can scale. So I want all of the things that we simulate at high frequency, I want that to be a bounded, known, low number. I want to have like a sub 100 number. That's the stuff that's on the screen and just outside the screen, where maybe you could hear it, or where effects would sort of trickle into the screen, that sort of stuff. I want that number to be low, and I want it to be controlled. But I don't want to put a bound on this number. I want this number to be able to scale up very well and not affect the runtime performance of the game. So that's what this low frequency concept is for. And so that's why we have sort of these two different types of entities and are doing more work to be able to support that. It's because we want to scale that up, and realistically, we're not going to be able to do high fidelity simulation on entities at this kind of scale, but we certainly could at this kind of scale, right? And so what I'm what I'm getting at here is that that means that calls like this that operate on all, like every single one, because if you remember, I can show you offset and check. That just loops through all the high frequency entities, and if they aren't inside the rectangle that the camera, the camera bounded simulation, which is bigger than the screen, it's camera bounds is perhaps a wrong term. It's more like the high frequency bound. In fact, we could say this is the high frequency bound, right? Because the camera is actually only looking at a sort of a different subset. So we're looping over every single high-level entity here, but that's okay. And while we may want to optimize that a little bit later on, we really don't have any pressing need to, because the number of high-level entities is low. So the degree to which that'll tank our frame rate is actually not high. It's not really that big of a deal. But the other one that we were doing, the other loop there, which loops over all the low entities, right? So this was the part that dealt with the high entities. The one that deals with the low entities, that one is definitely a problem. Because if we scale up the size of this array to be like 1 million entities or something like that we are tracking, there's no way that this is going to be performant enough, right? That's just not going to be sufficient. It's going to take too long to do this processing, and everything will slow down far too much, right? And we should probably, we could presumably demonstrate that reasonably well. In fact, I guess one thing I could do is just go ahead and demonstrate here. If I've got this, you can see that this is relatively performant. I mean, we haven't optimized anything, and it's all very intentionally slow and unoptimized code, but it totally is fine for playing, right? It's like there's nothing particularly problematic about this. It's totally workable, right? But if I were to go and add a lot more of those low frequency entities, which I could do with just a loop here that just adds tons of low frequency entities, right? So when we initialize the game here, what I could do is, this goes ahead and creates a bunch of rooms. What I could do is say, let's just go ahead and add a ton of entities as well, right after that, just a ton. I guess one problem that we have is we may need more space for our entities, because we haven't really, I think we're still at like 64 megabytes or something like that. So if I beefed that up a bit, if I said that was 256 megabytes, so we have more room of the permanent store for the game, and I just create, some dummy entity index here, I just create some really large number of these, right? In fact, I could just say we'll create as many as we have room for. So I'll do a while loop, and I'll do a while loop on that low entity count, and I'll just say while the low entity count is less than however many could fit in the low entity array total, right? Like so. Then I'm going to just add an entity, right? I'm going to add a low entity. In fact, I'll just add a wall, I guess. And we'll add a wall at some location. In fact, I guess we could add them all at the same location. We'll just add a wall out in the middle of nowhere. So it's nowhere near the camera. It's not relevant for it to be simulated or anything like that. But it's out there, right? So we have an abs tile X, abs tile Y, abs tile Z, right? And in fact, I guess one thing that I could do is I could just say that whatever that low entity index would be, right? Something like this. I could say whatever the low entity count is, right? Game state, like so. Oops. I could say that whatever that is, we'll make that be what it's, what it's, or I'll do this coordinate. We'll just call it coordinate. There we go. And so we'll make that just be, let's say 1024 plus this. And then we'll stick it at that coordinate, that coordinate, that coordinate in X, Y, Z, right? So we'll just stick it out in the middle of nowhere, but they're going to all be in different locations, right? So there we go. That'll add just a ton of walls, in the middle of nowhere, and I could run this, and it's only going to add a few at this point, right? Or it should. Oh, whoops, I guess I added one too many there. Right. While low entity count is less than array count, let's see, then we're going to add, why was that, what was the problem there? Assert game state low entity count is less than game. So why did I keep trying to add after that? What was the problem there? I'm gonna take a look at that. Sorry, this is probably just me. It's a Monday. You gotta cut me some slack here. So the low end account, and that's so why didn't we break out of that? Oh, duh. We need space for the player. That's clear. So I guess we gotta leave a little bit of room. We gotta leave a little bit of room. So for the player, otherwise we'll run out of entities. All right. So here we go. So now we've filled up the array to what 4,096 entities, right? So that loop is going to go over the 4,096 entities and see whether they're inside. And so let's go ahead and start cranking that number up and just see what we can go to. Now computers are really fast these days, so actually we'll probably be able to go pretty high. But let's find out exactly where we can go with that. So let's say that we change this to 65536, or actually let's just go ahead and pick that other number that I used. I used 100,000 before. So we'll now have 100,000 entities in here. Well, yeah, computers are too fast. I guess this is not going to make a very good demo. It looks like it's almost impossible for me to, to actually, since we're not actually doing anything than checking the rectangle bounds of these guys. Oh, but you know what? That's only on set camera, actually. So it's only when we move through. But even so, it's plenty fast, unfortunately. Yeah. Oh, well. So I guess this won't make a very good demo of why we need to do this. We actually have to be doing some actual work, it would appear, in that low check in order for that to really cost us anything. Computers are so crazy fast these days, it's insane. Like, you know, that's not the kind of thing you would have been able to get away with much too long ago. But anyway, so basically this guy right here was literally looping over about, I don't know, like 1 million of those guys, right? Somewhere shy of 1 million is what I typed in there. And so somehow that still manages to not be even a minor inconvenience for us. Now, if I had changed the set camera to operate every frame, I don't know if that would have been. So if we were doing smooth scrolling, for example, maybe that would have been something that we would notice. In fact, I could check that out as well. Let's go ahead and see here. It's so amazing how fast computers are. It's great. Let's see. Map new entities in and old entities out. New camera P. So basically, yeah, this is just... I guess I kind of just want to do this where... let's do it this way. Let's do it so we just track new camera P equals camera following entity low P. So it's just going to be, this will be just smooth scrolling basically. So that way it has to check on every frame. And it's still, I mean, that's still pretty zippy. I feel like that's still at the point where it's kind of, I mean, it's not a good frame rate, but it's not really a bad frame rate either. And I'm going to go ahead and step in there and this is in debug mode too. God. Intel, they saved everyone basically from themselves by making such crazy fast hardware. So basically this is happening every frame now. And the game state low entity count should be very high. Low entity count, right? Like you can see. And it's just doing these comparisons just crazy fast, right? It's just able to chew through those things incredibly, incredibly fast. You can go ahead and see it's got a fair bit of work to do, but it's all relatively straightforward. And it's just able to sort of plow through this at sort of a ridiculously enormous rate. So I'm not sure. I'm going to go ahead and try a little bit more to see if I can get it to the point, just to figure out where our bounds would have been, where the breaking point would be for the number of entities that we'd have to go to. Let's see. So how many do we have here? We've got 1 million entities. So what if I was to go up to 10 million entities? I don't even know if we've got enough room for those, but let's see. Yeah, I didn't think so. Game state is not even that big. So we'll try 5 million entities. So there we go. Now we've at least hit a boundary at 5 million where you can really feel it. It's really super sluggish now, right? And it can't hit frame rate anymore. It's way below the 30. So yeah, I mean, basically, once we have more work that we're doing, this will be more interesting of a test. I was assuming that it would have a little bit of a trouble doing, but I guess it was just so simple what it was asked to do. But so at that point, 5 million entities, that's kind of crazy how fast it can do that loop. So, all right. Maybe, based on that test, we really just don't care that much. If that really is the status of things, that we're just not feeling that much, then maybe we don't have to worry about it right now. What I was going to say was that I feel like we would probably need to replace that, and I feel like eventually we will, but man, like I said, computers are so fast, it's not anytime soon, I guess. I really wanted to make sure that we were only checking sort of some smaller subset of the low frequency entities, ones that were likely to be necessary to page in. And so what I was going to do there is put those low entities in a spatial partition, something that allows us to query them so that we can just get them without having to do a bunch of work to, you know, to figure out whether they were inside or not. So we just basically, you know, kind of be able to ask the world what are, you know, if the camera moves in a particular direction, right? Like let's say that the camera moves this way, be able to ask just what are the entities in this area and not have to look through all the entities to do it. But man, like I said, we just have so much horsepower to play with. Maybe that's just something better left for when we're doing the performance pass on things. So all right. This needs to be accelerated, but man, this CPU is crazy fast. And I guess it only stands to reason. I mean, when you think about how many pixels we're drawing just for the bitmap, it's a lot more than this, and the operations that we're doing in here just aren't that expensive, so yeah, at the end of the day, not much. But we'd like to get rid of this anyway because we don't want to be spending a huge amount of our frame time doing that either way. So, that said, and this is debug code, which is even better. We're not even compiling in optimizations at the moment. So that said, where do we go from there? Because that actually puts us in a pretty nice position. So what I would say is I would still like to go ahead and do one more architectural change, even though we don't really need to do it for speed purposes. What I would like to do is now go back and finally revisit our tile map. We made a hash table so that it could be properly stored sparsely, and that is something that we're doing at the moment. And what I would be interested in doing now is going, okay, maybe now is a good time to get out of the tile map business because, like I said, I don't really want things to be too tile oriented at the end of the day. So I just want to make, you know, I would like the world to be partitioned into sections that get loaded so that they can be stored sparsely and so that they can be, you know, paged in and out as necessary and these sorts of things. And so what I would like to do is maybe start looking at these as just things that hold entities instead of things that are in a tile map. Because I don't know, like playing with a tile map, it just didn't seem that interesting, and I feel like graphics-wise, we kind of want to have sort of more freeform stuff anyway. And so my plan was always to sort of use the tile map as just a guideline anyway, so I kind of feel like I might want to convert over. Now that we have walls or entities, I'm thinking maybe the tile map is just a thing that holds entities, and to the extent that it is tiled at all, it's just if those entities happen to be like things that we created that go in a tile-y fashion, then that's great, but they don't have to be, right? So that's what I was thinking. And so what I'd like to do is go ahead and sort of change the notion of the tile map here to sort of have a little bit more of that, right? To be based on storing entities, not on storing tiles that have data values in them, right? And so I've got two sort of ways I could think about doing that, right? Right now what we do is we store all the low entities in this big giant array here, right? And those low entities are then just processed, and like in that loop there, we just run over them all, or you know, if you have a particular entity that you're talking about, that's fine. So I've got two things I could do here in terms of storing the entities. I could put the low entities directly into the storage of the world, right? I could make it so that the world, the way that the world stores things is it stores the entities directly inside it, and then whenever you're talking about entities, you go through the world to pull them out, right? The other way I could do it is that the world is just a spatial index into the low entity set, so that basically there's just all the world stores is which entities, like the index of which entities are in any given tile chunk. Now, there's reasons to and not to do both of those two things. The problem with having the entities stored directly in the tile chunks, which would make sense for a lot of reasons. Like, for example, because we know we're always going to be thinking about them spatially, it makes a lot of sense to be able to say, let's process them directly, let's keep them all directly there in that memory block so that when we go to access what's in this particular point in space, we can just run over them right there and not have to do a bunch of chasing. The problem with that is that we end up in a situation where referencing the entities becomes difficult. So if we want to talk about entity 12 in a particular way, like so somebody's like following that entity or something, it becomes more difficult for them because it's very hard for that person to know where entity 12 is. There's no central notion of entity 12. So we would have to have a secondary way to look up where entity 12 is, right? On the other hand, if we do it the other way, where this just stores indexes into the low entity table, then we don't have that problem, but we have to chase those indices. So we're always looking up once in the spatial position and then looking up again. And really, we end up in the same situation there because those are basically just pointers. Those are basically just references to those entities. So we still do have the problem where when you reference an entity, you have to think about the fact that people are holding references to it, and if it gets deleted, they have to be updated there, and all those sorts of same things that you would normally do. So we do have, like, it's not a problem that has an easy right answer. There's different ways that we could envision doing it, and it's hard to know which one exactly would be the right way. What I'm going to assume is probably what we would want to do is I would assume that we probably don't need references to most entities most of the time, right? Like, most entities aren't being referenced most of the time. Like, there's only a few entities that are getting followed by someone, or a few entities that are getting chased by someone, or a few entities that are like inside of some other entity, right? So the ability to refer to entities is a less heavyweight operation than just the standard spatial processing of entities, which seems probably more common. And so, my gut feel with, of which one to implement first sort of suggests to me that storing the entities out in blocks that are along, like where spatial entities that are in the same spatial location are grouped together, seems to make a fair bit of sense. And so the question would be, if we were to do that, what would it have to look like in order for those people who do need to reference entities by some kind of permanent handle, basically? How would they do it, right? And so I guess I'm just going to think about that a little bit and see what that would look like, right? So let's suppose that we have our tile chunks here, right, which were previously storing tiles, but now they're storing like a bunch of entities, right? So now they're storing some low entity, some low entity block that's just a bunch of entities in here, and we'll talk about how we would store this later. But we've got something in here where we're storing these entities, and so now whenever we're iterating over things spatially, it's pretty easy because we can just see all of the entities that are stored inside this tile chunk, and we're good to go, right? Really, very simple. Not a big deal, but how do we refer to them indirectly, right? And what I would assume is that in order to refer to them indirectly, we would essentially have two choices. One is that all entities get a universal ID, right? And that universal ID is stored either in some kind of a tree or in some kind of array that goes along with them. So for example, in here we would have something like, low entity chunk reference or something like this, and it would have the tile chunk that the entity was in and the entity, right, and the entity index in that chunk, right, or something like this. Or we could just, if we don't ever actually need that particular piece of information, we could store just a pointer to the entity, but I suspect we would need that piece of information. So we'd store that, and we'd have sort of a set of those references. We'd have one for however many low entities there were, right? And that would be the end of it. That would be the table. And so anytime you had an entity, it also gets one of these things in here, and when entities get moved around, they're updated in this reference table. Seems totally reasonable to me. It wastes a bit of space, and so it's a little bit piggy, And the reason for that is because, like I said, a lot of entities are like a wall or a tree, aren't being referenced by anyone. And so we're paying the price to be able to reference them without ever anyone actually needing to reference them for any particular reason. And so another way to think about it would be, is there a way that we can structure things so that only the people who actually need to be referenced at any given time, and only the people who are having, essentially, who are have references to them that are being held, right, by some other entity or something that cares about talking about that specific entity. You know, could we figure out how to talk about that entity, have a handle them essentially only when that was true? And we could do that as well with sort of a double referencey kind of a scheme, but the problem there is it's hard to do that without bloating without basically paying the cost in another place. Because let's say we did something where we said, okay, we want to do that, so we'll only have this right here where we have like a reference count, right? Referenced entity count, and then we only have these references for the number that there were, right? So we only have a small number of these. You know, maybe there's some small number in a given time. There's not very many of them. There's a lot less, right? If you were to do that, though, the question is, when an entity needs to update its location in here, how does it know which one of these to update, right? Because the entity doesn't store any way to get back here. So we're zooming over these guys and we're processing them, and we need to change like their location or something like that, which tile chunk they were in or something like that, so they can be found again correctly. It's unclear how we would ever get back here because this doesn't store the information necessary to find it in here. We could search over this, but that might be expensive. And so we end up in a situation where it's a little bit problematic. And I don't know, we don't want to add more space here because the only reason that we were doing this in the first place was to save space. If we didn't care about space, we'd just have the giant array that had all the entities in it, and you just reference through that. So, it's an open question. And by the way, someone was asking, I think a couple of days ago, about slot maps, they were calling it. This would presumably qualify in the slot map category, although I never use that term, so I'm not sure I precisely know when people decide they like to use that term. But that's, what I'm sort of talking about here is basically a place where you can go to find out where an entity is when the entities themselves are kind of buried out into the world and need some kind of handle that can sort of indirect through to them. So there you go. That's my entire thought about all of that stuff. And like I said, I don't really know what I think the answer should be yet. And so again, like I've done many times, is I don't want to decide at this point. I want to just write code with it and see how it goes, and then we'll see what kind of matures from there. So what I think I would rather do is I think I would rather go ahead and say, let's just do a piggy version. It's not that pig. It's not so piggy that it's time for the hat. But let's do a piggy version, which basically says, here's the tile chunk that the guy's in. Here's the index inside that chunk of whatever the entity array is for the guy for this chunk or something like that, right? And then the referenced entities are always going to be in here, so we have a low entity count like so, and they end up being referenced this way. And then we're basically wasting memory at this point, right? This is memory wastage, but we're not really wasting CPU or cache because for the most part, everyone will be, normally querying entities spatially as we move through the world. And so for the most part, all of our stuff that actually does work on these should be relatively efficient. At least that's the hope. Okay. So I think that is what I will go with for now. And this will also solve our slowness problem where we cranked it up to 5 million entities and things got slow. This would presumably also solve that problem, so that's something that we can think about as well. All right, so let's go ahead and do some work here and think about how we're going to handle these tile chunks and that sort of stuff. Because I'm not sure exactly how I want to store these either, and so I kind of need to go through and think about that. I suspect what I would like to do is store entities in blocks. because I know that every screen will have a fair number of entities on it. There'll at least be walls and trees and that sort of stuff on every presumable tile. So every one of these tile chunks is going to have some number of entities in it. So what I'm thinking is I'll probably do something like this. I'll have a tile entity block. A tile entity block will store some number of entities, right? And it'll be responsible for kind of being the memory intermediary where I kind of allow things to, where things kind of coalesce. So that, let's say that we, in general, think of there as being 16 entities per block or something, and, and these things can chain together. So we basically have some number of tile entity blocks, and as tile chunks get filled up with entities, they use more blocks per, as they go, if that makes sense. Something like that. I'm not sure if that's, again, these are largely just speculative moves that I'm making here. And so, yeah, we're not sure exactly if that's how I want to do it or not. We'll see. There's complexity. There's a lot of complexities in here. So again, just playing around with it and see. And so what we do here is we go ahead and remove the tile chunks entirely. The tile chunks would be gone. I'm sorry, the tiles. And we just go with entities from then on. And we just sort of say, all right, we've got an entity block. That's our first block. And that's really the only thing that we would need here. And then as tile chunks get filled up, they just kind of fill up with these blocks. Now, since all tile chunks pretty much have the entities in them, I'd probably just leave that first block in there directly. So you always start out with one block. And that block, probably should also store its fill level, so the number of entities that's actually in the 16. But even that may not be necessary. What we could do is actually have the entities so that they basically have, a is present, not present, and then we always process them, say, 16 at a time. That's also totally plausible. So just thinking this through again, I'm thinking like, okay, so that'd be fine. I'd store my entities in there. That's all good. So we've got the entity blocks and they're all good to go. But there's another thing there. There's really two things that I could do too. I could also choose to store this as just having more tile chunks. So instead of having there be tile chunks and then off those you have entity blocks, I could make it so that I just have tile chunks, and tile chunks are oversubscribed. So you keep going and you process all of the ones that you see that have the matching tile chunk X, Y, and Z. Not sure if that's a good idea or not, but just pointing it out that there's something we could do. So I could say, as a to-do here, could make this just tile chunk and then allow multiple tile chunks per hash bucket, per XYZ, I should say, right? So we could do that. Not sure if we want to do that, but we could do that. So if I do that, then I'll be able to store these guys. And then, so the main thing that I'm thinking about now in terms of efficiency, right, is I've got these high entities, and the high entities need to be able to write back their low entities. And so this right here would be the primary place where I'd have to be doing that pointer chasing in a kind of an inefficient way, right? Where this is going to have to go look up in here and get back there. And that's really the place where I'm most concerned about it, because that's the one where it's going to be most heavily hit. Because people snapping references to other entities where they're like following somebody, those kinds of things, I don't think are going to be as prevalent, but I don't know. So it would be interesting to me if I could figure out some way of, some technique, some structure there that would allow those to be a little to be a little more logical, right? That would allow it to access it a little bit better. And I'm not sure what that way would be. The one thing I will say is that does kind of argue that maybe I really do want that. Maybe, okay, so this is kind of interesting. I'm glad I'm walking through every single step of this. Thinking about that some more, that may argue for going the other way with it, right? Because since the high entities want to constantly write back into their lows, at that point, the tile chunk iteration is only for moving things in as you move the camera around. It may mean that the indirection really should be on the other side. So that, I think, maybe makes the determination for me. I think that may do it. So essentially, I think this might be the way it should go. So these are, in fact, going to be the low entities. They are going to stay in here, and they'll be direct. and then people will always use those to directly access them. And then what we will store out here in the tile chunks is just for any given tile chunk, here are all of the low entities that pertain to it, right? And so basically, that is what we would turn. This would no longer really be a tile map at all, which is what I was trying to get to. It would just be something where, you know, we are sort of storing that large spatial partition of our entities so that we can scale them up as large as we want. Because yeah, like even in here, you know, you did see it eventually got slow when we scaled it up to 5 million. And so I don't want that to ever be a problem where as we start to do more work on those low res entities or any other sorts of stuff like that, I don't want that ever to be something that we're actually spending significant CPU time on, especially maybe on lower end CPUs than the one that I'm using and that sort of thing. So I think that's roughly what I'd like to do. So I'm going to go ahead and do that. And let's say for the moment, we'll just go ahead and implement that directly. I think that most everything that we need to do is already now done, structurally speaking. We just need to start actually operating on these entity blocks properly. So let's go ahead and do that. So first things first, we need to, well, why didn't I get any? Oh, I know why. Because first I've got to delete a couple of these things. So basically, like get tile value and set tile value are now no longer useful to us, right? So those things kind of need to go away, right? You're not allowed to set a tile value anymore for the most. So I'm gonna start vaporizing these guys slowly. You're not allowed to set a tile value. You're not allowed to get a tile value anymore because those things are relatively meaningless. They don't mean anything, right? Because we're just going to use entities for all of that stuff. So we'll go ahead and get rid of that. We don't care about any of this stuff. This is all going away. So let's go ahead and compile that. And we've already eliminated most of it from here anyway. It was like this was it. The set tile value was really all that we were calling, right? So we can continue to vaporize that stuff pretty much all the way up. Get chunk position 4 is probably still important though. That one we're going to need just for doing our own accessing. So that's fine. But let's go ahead and we'll save that guy. Let's see, set tile value, get tile value unchecked, and then get tile chunk. So I think we're mostly looking at this, right? So all of this stuff would basically go away. All of that stuff would be done. So let's push that all down. Let's grab it out of here, right? I'll stick it kind of at the end of the file, like so. See there. Hopefully there's no other comments in there. Yeah, so it's grayed out. Everyone knows it's gone. And so now we have our get tile chunk and we have our get chunk position 4, and those are things we actually do want. And then we can start to move forward. So let's see here. Tiles, yes, that's true. That is no longer an active member. Tiles is not a member of tile chunk. Let's see, that's true. Now, what's interesting about this is when I do that push array, so there is one thing that's a little janky about that. Let's talk about that for a second. So if we talk about having this tile chunk hash here stored, so since if we actually store these directly in there, we are starting to balloon that out. This is getting relatively large, right? So the size of this chunk hash is actually pretty large. I don't know that that's necessarily a problem because, like I said, you kind of want it to be direct access like that. But it does mean that empty slots in here are starting to take up a lot of space. And so I do worry a little bit about that because remember, the reason there's two ways we can implement this. One is that these are pointers, right? So that there's a 0 in there if there's no chunk hash and not if there's not. And the other way is the way we were doing here, where the tile chunks have some notion of whether they're filled or not. And so the only reason that I wanted to do it where they were all there is because that way you don't have this double pointer chasing going on, where you look it up and you gotta look it up again. But we do have a problem, which is if we want this hash table to be relatively sparse, we're paying a lot of extra space if we don't have the extra pointer there. So I'm starting to think that maybe this should just be a flat pointer. and we'll just bite that initial double indirection, and then we have everything packed in there after the double indirection happens. I don't know. It's tough to say. Like I said, this is the sort of thing that it's really difficult to know. So I feel like it's premature to really do it one way or the other. We'd have to start timing it to see whether it was expensive or not, right? Does that make sense? So I'm just going to mark that. And I'll say tile chunk hash should probably switch to pointers. Switch to pointers if tile entity blocks continue to be stored on MOS directly in the tile chunk, right? So basically what I'm saying is if this becomes a pointer later on, depending on how we do this, or it's small, then it's totally fine. But if it continues to be a large flat array of 16 or something like that, then I think we have a problem just in terms of the space wastage for the empty slots in the chunk hash. That's my thought. So we'll see. Anyway, moving on. So we've got our low entity indexes in here. So now what we need to do is just start storing those, putting low entities actually in there. And so this can all go away, and we're done. And so like I said, the Handmade CPP is now not even using that. It's just, like I said, it's searching all of the entities every time. So it's totally fine. And Mr. Walks Around here is unaffected by these changes because really he's not using what's the word for it? He's not using the tile map at all. Okay. And so what we can do now is, this would be a good point to rename it from a tile map as well. And since we have that world, I'm going to go ahead and say let's start opening up Handmade World. We'll make Handmade World, which was a thing, be our new file. And so handmade tile.cpp, I want to keep most of this stuff, right? But I'm going to start to rename it. So I'm going to move it in here. We're going to go ahead and vape this file. So this file goes away. Delete file, handmade tile.h. Goodbye. And then handmade tile.cpp I'll save as well. Just these guys. So. And then this can kind of go away, I believe. Delete file, handmade tile.cpp. Goodbye. And then I've got my handmade world.cpp. And in theory, let's see, save. In theory, that should cause us to have to do that. There we go. And this as well. Okay. So now that we've got that, let's go ahead and start working on this a little bit more. So now we had this world pointer before, right? We had the tile map structure before. Where did that guy go? We had a struct world. There it is. And all it held in it was tile map. And now what I'm going to say is, all right, we kind of know what the world is now. The world is a collection of entities. So I'm going to go ahead and say that this is the world, right? And you no longer have to double dereference out of it. And then what we've got here is we just have a world chunk. And the world chunk stores everything in the world at a particular area, right? And we've got the world chunk hash, and that's going to be all referenced in here, right? So we've got we've got our world chunk shift, our world chunk mask. So now we definitively kind of know what this is, and that's good. So then in here we've got the world chunk, and we've got its X, Y, and Z positions, and we've got its entity block. So I don't know what we want to call that. There's probably a better name for this. Let's call this what are we going to call this? It's a good question. I'm not entirely certain. I'm not entirely certain. I'm also kind of tempted to do that thing where we just have both of the world chunks there, where we just have more world chunks, and you just kind of look for one that's empty. It's kind of tempting. It's one of those tempting things. Yeah, you know what I'm saying? Like basically, you know, these are that, right? and then it's this, and that's the whole thing. It feels like a good idea to me. Feels kind of like a good idea to me. So we just look it up in the spatial hash, and then we kind of crawl through the hash looking for every hit. It's just, it's so crazy that it just might work, as they say. Such a tough decision which to go with first. Like I said, eventually all things become clear when you go and do them, but sometimes it's just kind of fun to think and guess and be like, which one do I think is going to be the one that I'm going to like more? And I don't know. So, obviously I try to prune and get rid of things that are obviously going to be stupid. But at the end of the day, trying it's really the only way I ever know. And so, really I probably would have to just try it. The reason that I think this is kind of interesting is because it just simplifies things a little bit. But it is nice to be able to pull out a chunk and be able to hand that chunk back to somebody and say, okay, you don't have to do any more testing. You can just sort of follow through. Like, I'm thinking that basically someone queries, right, this thing, and they get back a pointer to the entity block, and they just can like walk through that entity block. So it's going to be cleaner that way. I don't know. So many hard decisions. All right. Anyway, that's all that. Nothing particularly tricky there. So then what we have is in this is the position of a tile inside the world inside those blocks, which I don't think we care anymore about. I'm pretty sure tile chunk position is just not relevant to us anymore. So I think we can get rid of that entirely. And then tile map position is kind of interesting. What tile map position was previously used for was basically a way for us to determine, where things were. We have an interesting opportunity now, which is that the chunk X, Y, and Z does allow us to know sort of where the guy would be if we had the offset plus we knew which one he was in. So any time that we iterate over the things in one of these blocks, these are not necessary. We wouldn't have to store these anymore, which would be great because that means we don't have to store them. We don't have to save them. They're not important anymore, right? Because instead of storing what tile you're referenced to, you could just store which world chunk you're in and then the offset relative to the world chunk, and you'd be good. Why am I hesitating on that, right? Well, the reason I'm hesitating about that is because, come back to me, there we go. The reason I'm hesitating on that is because what do you do when you get to someone through a reference? So I'm an entity, I'm following another entity, I go, oh, that guy, I need to follow that guy, where is he? I can look him up in his low entity structure, but I have no idea which tile chunk he's in, right? So how would I go and find out? Because I'd have no way of, I'd literally have no way of figuring that out, right? There's no way to know that. It's pretty tough. It is pretty tough. So that's kind of why you need this, is because this is what lets you get back to the chunk that you were in so that you can update yourself properly or know where you are. So it's frustrating because it would be really nice to be able to store this in a compressed form, and everyone who operates on things per block wouldn't have to worry and would be able to just do that. But I can't think of right now how I would do it so that when you're going through the low entities in some other method of indirection, like from the high entities, right? Going through them. Although with the high entities, it's okay because since we know your absolute location at that point, actually, we could figure out where you were. We could go re-look you up in whatever tile chunk you came from. So that's not so bad. So I guess high entities aren't the problem. It's just if a high entity or a low entity is referencing some other entity that it's following or something like that, it goes and says, where is that guy? It just doesn't have the knowledge to get back there. So man, that's frustrating. So that frustrates me because that's such a special purpose thing that's going on, but we need to support it. So the question is, again, is there something we can do that's a little cleverer here so that our structure would support that and not have to store this extra information, right? I don't know. I don't know. That's a puzzler. That is a puzzler, my friends. So I'm going to go ahead and say, to do, Casey, puzzler. How can we get rid of abs tile star here and still allow references to entities to be able to figure out where they are? Or I should say, or rather, which tile, which world chunk they are in, right? And that's just, yeah, like I said, that's really tricky. That's really, really tricky. So basically, we've got, we don't really need to call these world map position. We could call these just world positions now, right? We could just call that world position and world difference, I suppose, because, yeah, world difference will be replaced by just a vector 3, I think, in the future. We don't really need that one at all. But let's go ahead and fix some of these compile errors here. Call that world chunk. That's the next in the hash. Let's see, tile map position. So tile map position is now just world position. I get some of this cleanup. We've talked about some of these things before, but you know, I try not to do anything until it's really obvious that it's time, because I feel like that saves a lot of kind of a lot of going back and forth. Okay, let's see here. Low entity chunk reference, we got rid of that. That's gone. And let's see, tile chunk. So there's world chunk. Let's see, and this is world. So tile map is now world, essentially everywhere. So world, 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 world. There we go. Okay. And similarly, tile underscore map is now world. So that's there we go. Keep on going there. See where we're at. So tile chunk hash is just world chunk hash. So I guess tile chunk becomes world chunk as well. These are the kind of things that I really wish we had better built-in support for. There's some like refactoring tools and stuff to do this, but I just wish that we had just better unified like tools for this sort of thing, because it's just kind of stupid that this sort of thing even happens. It doesn't take very long. It's not a big deal, but it is just kind of lame, right? Okay, so these are, let's go ahead and replace world chunk with just with chunk. So there we go. And all these guys can be, oops, one of those guys was not supposed to be, it's not supposed to be replaced. That's okay, it'll complain. It'll complain for us. There we go. World chunk hash. I don't even know, I suppose I could just change that as well though. We could just call this, because, you know, what other chunks are there going to be? We're calling these chunks, so we'll call them chunks. There we go. All right, so replace that. And keep going. Next in hash, world chunk. What else we got? World. So world chunk position. Is get chunk position 4? We don't need this anymore, do we? This is strictly something we only need to compute these. So world chunk position is really, if we deleted that guy because we don't actually need him anymore. All we really need is the abs, the chunk X, chunk Y, and chunk Z. And I think we're probably going to get into a situation where we don't super care about that as much anymore either. So I'm just going to go ahead and if zero that guy out. And when we do tomorrow, when we do empty insertion, we'll go ahead and deal with that at that time. Okay. So let's see. World chunk hash is just chunk hash now. What else we got? Chunk hash. Chunk index, world chunk becomes chunk. There we go. Easy enough. Tile map difference is just world difference. Tile map is just world. Let's see here. Again, same thing. And we'll be able to get rid of that tile side in meters as well. So this will be pretty good cleanup, but we'll have to tackle some of the more important parts of it tomorrow, unfortunately. So let's go ahead and say that we've got world there. So tile map becomes world. Wherever we see that, world, world, worlds. Of course, these are a lot of those are world arrow worlds. So we'll have to clean that up in a second. So world arrow world just becomes world. That's pretty easy. There we go. And tile map becomes world as well. World, 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 world. And there we go. Game state. That's true. That is not necessary. I agree with that. And there we go. So let's see how badly we broke things. Pretty badly, it would appear. So let's see if we can go ahead and fix that. Hopefully we have not broken anything too horrible with all of my ridiculous renaming. So let's see here. Oh no! Oh, but we were just almost there. Well, okay. What is the problem here? Map into tile space, move player, game update. What was the problem? What is the problem here? So let's take a look at. I guess I should look at what got initialized. Let's see here. World. All right, so world is not being initialized. That's really the problem that we have. So initialize world. Let's go ahead and see. That is just garbage. That's all totally garbage. So that needs to go away, like so. World star world equals that, and there we go. Okay. So now we're back to square one, so that's good. And we're in good shape. So we can start the Q&A, so that's totally good. So basically where we're at, just to give a recap, is now we've got sort of a sense of how we're going to store the world. There's only really one large outstanding question for me, which is if we get rid of the notion of tiles entirely, right? So we still need a notion of where things are that's resilient and scales to very large floating point values. And so what we're going to have to do is this world position is still going to have to be relative to something. Now, it can be relative to the chunks, but it's going to be interesting to try to think about exactly how we do those mappings. In other words, like when we have something like this, in the Handmade hero thing where we do the set tile and that sort of stuff, right here, like when we're adding our walls. So now that we know that the walls are not going to be at like abs tile locations, we just need a way of like cleanly being able to say, okay, I'm working on a room, like maybe like here's the center of the room and here's where I want to put the, the things. And we need some coherent way of talking about those things such that we can create the world so it's nice and continuous, but that's, such that we can still have it be resilient and not have problems with float precision, right? And so that's the interesting thing, because I'm not sure exactly how we're going to do that if we stop thinking about things in tiles. But that's really the only thing. The rest of it is just little performance-y things that like later on when we get to optimization we can think about more heavily. So all right, we can do the Q&A now. Please put Q: before your questions. And if you could, keep the questions to things we've talked about in today's stream or on a previous stream, because that helps tremendously. If you want to do off-topic questions, come about 15 minutes before the stream starts. We do all kinds of off-topic stuff then. Do you still expect the gameplay to be broadly grid-based even without tiles? Yes, to some degree. Like, I feel like the gridness helps the players think about it that way. And so I don't really know exactly how we're going to do some of that stuff, but I do expect to try to keep things to be sort of grid-based for player understanding, basically. But what I want to be able to do is make it so that the engine supports arbitrary things, so they don't have to be grid-based. But we'll still sort of create them on grids as necessary when we, for understanding. Could you use reflection to help handle the entities and world chunks? I'm not sure what you mean by help handle. Could you be more specific about help handle? Like, what is it that you think that reflection would help in terms of handling? If that makes sense. Not very many questions today. Of course, that makes sense. We were just sort of doing some pretty basic code changes here. Although I kind of was hoping someone would talk about... I was kind of hoping someone would figure out how to do a good collapse for these so we don't have to store them. That'll be kind of interesting to see. I hope we figure something out eventually. Will everything in the game be an entity even if it doesn't need collision detection or movement? So if there are things that don't have any aspects of entityness at all, then we might, right? But I feel like we want most things in the game to be dynamic, and I feel like the game gets richer if we allow everything to sort of be an entity. I mean, to give you an absolutely absurd example, like, you know, let's say, you know, you get a magic wand that allows things to turn into entities. Like, so I wave the wand at the wall and it like grows legs and walks around. That'd be pretty great. So it's those kinds of wacky things that I think it's interesting to enable. And so I kind of feel like making everything an entity is just kind of a nice thing. And then figuring out how to make entities very dynamic so that they can represent walls or represent real things and scale between those nicely is a more interesting direction to go rather than hard coding what the difference is between a piece of scenery and a piece of interactive stuff. But who knows? We'll see when we actually start coding the entity stuff how hard it turns out to be to make those things realizable. Don't you think most of the storage concerns stem from having just high and low entities and would be solved by having more granularity there so you have more and smaller arrays of entities with some particular aspect? I don't think so, and the reason for that is because, like I said, I want the concept of entity to be very dynamic in this game. I want things to be able to very broadly be able to support a lot of different mix-in sorts of stuff. So I just don't think we're going to be able to have homogeneity. I think homogeneity really won't be possible with the game design. If I thought it was going to be very homogeneous in that way, we absolutely would do that because it'd be much better for performance as well. You mentioned considering having the world chunk store a fixed entity count and then add multiple chunks to the hash table if necessary to store more entities. If you were to go that route, how would you compare one chunk to another? Multiple chunks would have the same XYZ. So the answer would just be all queries into the hash table would walk all the chunks that had the matching XYZ. So basically that lookup, right? This lookup right here, instead of stopping when it found a match, would just go through and actually use every single one that it found. Instead of this break, it would basically process one and then go to the next one and process that one and so on, right? And so the only reason I didn't do that is because C and C++ don't make it very easy to do visitor style stuff. Like basically normally in other languages you just patch closures in here and they just get executed. And C++ 11 is a little bit better about that, but it's still just, it's not a language that's really built for that. Just bottom line. And so, you know, I was sort of staying away from that because it'll be easier if this hash lookup can just return to you a chain and you iterate over it rather than doing it the other way around. But that may change because it's not that hard to make a little iterator here that you would use to crawl over them. And so we'll see. I may just do that. In terms of handling entity compression and decompression, where would you store the state of objects that are coming in and out of the update scope? So that is just in set camera, right? So this is the thing that basically stores stuff back, and this is the stuff that pulls stuff in, right? I think is that what you were asking? I'm not 100% sure. Why do I call C compiled with a C++ compiler C++? Well, because this isn't technically C, right? You couldn't write, this wouldn't compile with a C compiler. So for example, if you look at here, we've, these operators and stuff, that's all C++. So this is definitely C++ code. It's not C code. It's just we don't use much C++ because most C++ is not particularly good. But there are some language features of C++ that are good, and so we do use them. So technically, we're not C. Why can't world position just have a pointer to a world chunk instead of all those abs tiles? Then offset underscore is relative to the world chunk. So the problem is that doesn't really save us much space, right? Like, I mean, it might save us a little bit of work, so that's not a bad thing to do, right? But this is, this is 32 plus 32 plus 32, right? So it's 64. It basically would save us half, right? Because a pointer a pointer here is going to be 8 bytes, whereas we're using 12 bytes, right? So it's not like getting rid of all of it, which would be much better, right? Saving 4 bytes versus saving 12. And furthermore, you're kind of in a little bit of a rough position. If you put a pointer here, that isn't really all the information, if that makes sense. I mean, it sort of is in some sense, but it sort of isn't in another. With this, you can actually figure out where in the hash table something is, whereas without that, you can't. So for example, if you just have a pointer to a world chunk, let's say you wanted to remove that chunk from the hash table, you wouldn't be able to do it because it doesn't store pointers back to where it is, right? So that would be kind of a bit iffy. But I guess at the end of the day, that's not really true because you could use this to back it out. So you'd go to the world chunk, you'd back it out, and you'd go. So as long as we continue to store the complete XYZ in there, I guess that's totally fine. So yeah, so it's still fine. Storing the pointer would be fine. It just doesn't get me as much of the savings as I want. I would like to figure out a way to just nuke this entirely, if that makes sense. But, maybe that's not possible. I didn't get to watch the entire stream, so I don't know if you considered it, but why don't you have a flag for about to be deleted that every entity checks against and nulls pointers? Have it visible for all entities for one frame. So the reason I don't do that is because not all entities will be updated every frame. Especially the low entities will get updated at a very low frequency. That's why they're called low entities. So they may be updated once every 60 frames, for example. So using a deferred deletion strategy like that really isn't an option for us. We probably still will defer deletions to the end of the frame for other reasons, but we won't be able to use that as the way that we get out of jail free for deleted entities. But that's not what we were talking about here really either. So just to be clear, I wasn't worried about that. I was literally just worried about the fact that as things move spatially, they will move where they are in the world storage, right? And so that was the thing that I was worried about, not that entities would be deleted. That really wasn't the problem. Do you think the to-do puzzler will be handled tomorrow? And do you often sleep on decisions like that? I do often sleep on decisions. Most of the time, I never do anything right the first time. I have to sort of play with it, and then I think about it, and I'm like, that's what I should do. And so that's why I try not to think it through too hard. I try to do a little bit of due diligence when I'm writing things, and I'm like, okay, does this seem right? Let's juggle it around. And then I just go and I make that thing. And then later I think about it and reflect on it and go like, okay, I should have done it this way, and I do it. Because usually I find that I have to see the thing to really know, because there's a lot of complexity, and it kind of like sinks in, and then I'm like, that's the thing. I don't think it'll be handled tomorrow. I think that we'll have to get a little further down the road, and then we'll see how the low entities get updated and that sort of stuff, and then we'll kind of go, there's how we do it, and then we'll do it, if it's possible. What I was getting to is that we seem to be working towards what's called the entity component system, where what we call now high and low are just components alongside anything else we want to add to entities later. Yeah, well, so it's hard to say. I mean, that may be true. But like I said, I don't really like to pre-guess those sorts of things. I'd rather let them emerge properly so that they are guaranteed to be right for the model that we're actually using. So I do suspect we will have components, but those components will probably be part of the low entity because they never get deleted, right? They're going to be there forever. And so presumably the high entity is really just a thing that stores like the animation state and stuff like that. And so I don't see much benefit in trying to overthink that and making some generic way of handling it when the specific way of handling it I think will be what we actually want. And so if that makes sense, hopefully that makes some sense. Seeing that the computer handles 1 million entities without lagging, do we really need to worry about the performance hit coming from one extra pointer dereference? So yes and no. I mean, you're right. Probably not. But what you have to remember is the pointer dereferences are the really bad things a lot of the times. That case where we're looping over the entities is the best possible case. It has no pointer dereferencing. It was just a loop that's completely streaming. So the memory is read in complete sequential order and is the perfect case for the processor. And so pointer chasing is actually much worse than that. It can be, up to 200 times slower than what we were doing, right? And so yeah, I am a little bit worried about it, just from the standpoint of like, if we actually want to scale things, I don't want there to be a lot of that. But realistically, no. I mean, at some level, we don't care too much about some of these things because like the tile chunks won't be accessed at a frequency that's high enough to make the extra pointer reference really that big of a deal, and stuff like that. So we'll see. But again, I like, this is also some practice. I mean, the idea here is not to just do the sloppiest thing that works. It's to actually think through everything and program it as if it were intended to be professional and that we don't want to spend a lot of time doing things that we don't have to. Because again, this is educational. It's not, the goal here is not to ship the game as quickly as possible in as piggy a way as possible, which would be a different skill set, right? It's to sort of show how to think through problems and do efficient systems, because a lot of times you do have to care about efficiency. This just doesn't happen to be one of them because, at the end of the day, that particular loop is not going to be a problem. Although who knows, on the Raspberry Pi, maybe it will be. We're on the best possible case right now, so keep that in mind. Like, things get a lot worse when we step down to mobile or whatever, right? Will entities be able to transfer from one chunk to another? Yes, that's all the entities will always transfer from one to another unless they're pure scenery, I think. So anyone who moves will often switch between chunks. Will we start using the entity system for something other than players' walls soon, or will the renderer come first? We'll probably add a few more things in there for testing purposes, like, pickups, chests, an enemy or two, something like that, just to get it working correctly so that we're seeing roughly what'll be in there. And then we'll do the renderer, if that makes sense. How are we looking here? Is that the end of the Q colons? I think that may be the end of the Q colons. I'll give it a second just to make sure. Just to make sure. Looks like that is the end of the Q colons. I believe we have reached the end of the Q colons. So, I think that's about it for today. We will wrap it up here. Tomorrow, what I'd like to do is go through and actually start using the world as a spatial partition where we put stuff in it. So we'll go ahead and implement that code. And then that'll pretty much be, and I'll go through and probably pull out some of that code that's in handmade.cvp right now that's about moving things in and out of the active sets. So we'll just play around with just cleaning that up a little bit and making it a little more formal, exactly how things work, trying to get it down to something relatively straightforward that's very clear and easy to follow. But I think that's about it for playing with how the world is stored. So then we'll try adding, like I said, a couple more entity types, just play around with it a little bit, maybe try to create a bit of a sprawling world, like make a stupid generator that generates a lot more stuff, and make sure that we handle it, right? Make sure that you can walk around the world with a million entities actually placed and that it all works okay. And then we'll kind of consider this part of things done for now, and we can move on to the animation code, which we do need to prototype as well before moving on to actual any real straightforward work on engine components like the renderer. But again, things seem to be going pretty well. I do wish we had like a slightly better solution for a couple things in here, but those are the kind of things that usually shake out over time. You kind of start to see, oh, I should have done it this way, and then it's a little bit clearer and it's fine. So I'm not too worried about it, but there are a couple things that still bug me. So hopefully we'll get all that stuff ironed out at the end of the day. But for now, that is the end of our coding. Oops, what did I do here? Did I edit? Oh, there we go. Okay, make sure we're still compiling. So thank you very much for joining me. It's been a pleasure coding with you as always. If you would like to follow along at home with Handmade Hero, you can pre-order the game on handmadehero.org, and it comes with all the source code. You can download the source code every night after I finish coding here on the stream. I upload it. So you can play around with it and learn to program games yourself as much as you would like to. So if you'd like to do that, handmadehero.org, hit the pre-order button, and you are good to go. If you want to support the video series, we also do have a Patreon you can subscribe to. That's clickable over here on handmadehero.org as well. And then we also have a news and forum site that I highly recommend people check out if they're trying to learn from the stream. The schedule's here, although I also have the Twitter bot now. It's Handmade Hero on Twitter now tweets the schedule properly as well, so that's good. But it also has an episode guide for catching up on past episodes. It's got a coding resources guide, which basically has everything in it that you might need for porting to Mac or Linux. People have done work on moving it to platforms that we haven't gotten to yet, so that's a pretty cool place to check out. And we've got a code discussion forum where you can go and ask questions if you have questions. I highly recommend checking it out. So thanks everyone for joining me. I'll be back tomorrow at 8 p.m. PST, where we should be able to wrap up some of this world stuff, hopefully. And I hope to see you all there. Thanks for joining me.